Hello friends, welcome to my channel and explore the world of Microsoft Azure. My name is Rajneesh Kaushik and I'm a Microsoft certified trainer, consultant and an enterprise architect. For more latest videos and blogs, you can always log into my website rajneeshkaushik.com and subscribe to my blog. Please do not forget to subscribe my channel and click the bell icon so you don't miss the latest videos. Do like, share and comment.
Today's topic is building reliable data processing pipelines with Azure Databricks Delta Live Tables. This is a part one of series of two videos. Part one will be concepts and part two will be demo. So let's get started. Here is an agenda for today's video. Here is the agenda for today. First, we will understand the Lakehouse platform and then how a typical Lakehouse architecture looks like. What are the complexities involved in building a data pipeline? And then what is Delta Live Table? How it helps you to understand the dependencies between different sources and then ease the development process, and how this Delta Live Table helps you to treat your data itself as a code and then trust it. What are the different features it provides in terms of reliability and maintenance, and what kind of workflow management it provides out of the box. Then we will understand the different part of the Delta Live Table, the pipeline settings, datasets, pipeline modes, and different editions of Delta Live Tables. Then we will understand the environment independent data management concept, and then the what is the process of event monitoring in Delta Live Tables. And then we will understand what is our demo use case, and then I will start a demo wherein I will show you this working version of Delta Live Table in Azure Databricks. So let's get started. A typical Lakehouse platform. What does it mean when I say Lakehouse? So Lakehouse has different layers. So on the first layer from the bottom, you have different set of datasets. Like there is some structured data, semi-structured data, or unstructured data, or some streaming datasets, right? The streaming datasets coming from the Kafka or Stream Analytics, and then those data is coming. All these are the different datasets. Now, this particular data is being ingested into one of the cloud platform, whether it is AWS or Azure, or if you're using a open data lake, which is Hadoop data lake on premises, or Google Cloud. So this data is getting ingested in one of them. Then apart from that, this data is secured by a security and administration layer. And then there is another layer for management and governance of the data. In Azure Databricks, this layer is a Delta layer, Delta Lake, which is a abstraction on the top of the data lake, ADLS Gen 2 or any data lake provided by different platforms. This is actually the main part which helps you to manage the data and enforce some governance around it. And then finally, you have different integrated, different collaborative role-based experiences. Like there are different set of people, data engineers, data scientists, and then machine learning specialists who's trying to consume this data from this layer. And there are some applications which is consuming this data. There are some BI reporting platforms or SQL analytics platform which is consuming this. So these are the consumers. So this is how the typical Lakehouse platforms look like. Now let's go to the next step and understand what is a typical Lakehouse architecture looks like. So in this typical Lakehouse architecture, if you see on the left side, there are these data sources, right? The data sources could be JSON file, CSV file, or TXT file, or any different set of files, or the data might be coming from SQL databases, or it might be coming from the streaming systems like Amazon Kinesis, or SQL database, or a Kafka streaming data sets. And then whenever this data is coming from in any of these data sources, this data goes into multiple transformations. So first transformation happens on the data is that this data is ingested into the bronze layer. and bronze layer is nothing but a raw data set which is coming as it is without any changes in the data set, and it is landing as it is, and it is used the way it is coming so that we can use it for the auditability purpose. Then the second step is silver layer. In the silver layer, we try to handle the missing data, like suppose there are some columns which is missing and there are some schema which is not, the data is not as per that schema. We try to clean up some fields. We try to, there are nested objects inside the structure. You want to demux that and put it in a flat format. And then there are some data which is coming in a very different naming for the columns. You want to put a very friendly names to it and rename those columns, and then you want to enrich this data by adding some extra attributes to it so that it makes more sense to the business. So this data is actually silver zone, which is a filtered, cleaned and augmented. Then this data moves to the gold zone. And why we need a gold zone is because the gold zone contains the business models, different aggregates for dimensions, the business friendly field names, because in the silver, the field names were there, but it is not business friendly names, right? Which business could understand it. And then there is some common logical views which is created so that business can actually consume it when they try to search this data or query this data. Now, after the gold zone, this data is ready to be consumed. So this is a consumption layer. Now, the another applications like stream analytics application or Power BI, Tableau or Kibana reports, right? Or any data science and machine learning libraries or applications, they can consume this data here. And obviously, this data also has some data quality characteristics, like there are some applications or some code which is already running, which is making sure that this data is of high quality. And if the data is not of high quality, it is already rejected there. So this is a typical lakehouse architecture. So there are lots of complexity involved in building a data pipeline. Why it is very complex? Because it is a large scale data. You are ingesting petabytes of data, okay? And this data, there are lots of pipelines, hundreds of pipelines running. And if there is some problem in your pipeline, there are some downstream system which is consuming this data, and they are relying on your data which is coming from these pipelines. And if there is something happens in your pipeline, then the downstream system is stuck up, right? And then moreover, there is so much work involved to convert the SQL queries to the ETL pipelines, because if whenever you write some logic, right, predominantly you write this logic in a SQL code. But when you want to convert into ETL, there are specific set of ETL constructs provided by different ETL tools. Like ADF provides its own way of development. Informatica provides its own way of development. But ultimately, the basic fundamentally, all the data is might be coming in SQL queries, or can be SQL queries can be used to do the queries on that data. So this is a tedious work because you need to again convert it into ETL pipeline. Then because there are different tools to convert it into the ETL, so your focus is predominantly on the tools instead of working on the real development, or okay. And the focus is not on the complexity of the data, it is majorly on the tool. How do I use this tool to develop this functionality? Like in ADF, you will think about, I will use data flow, and I need to spin up the data flow cluster for this. Or in similarly, if you want to use Informatica, then you need to understand how Informatica construct works. So first problem is that the ETL pipelines are too complex, but instead of focusing on that complexity, your focus is moving towards the tools. So that is stealing your focus. And then moreover, whenever the complexity increases, right, the operational operational ability also decreases. So how do you operate it in a large scale? That is another challenge, right? So these are the issues, and it is difficult for going from query to production. Like you are querying the data with a basic SQL statement, but when you want to productionalize this pipeline, right, this is too difficult. So what are the complexities involved? Okay, so first complexity is this, that there are different business analytics, right? And they want to understand that why this pipeline is still two jobs are filled but other pipelines are still running. Okay, why the system is broken? Okay, what are the sources for this table, and if what are those sources, and how do I understand that these sources are built correctly. Can I, the ML model, ML folks, they want to understand that can I get this data faster than what I'm getting now. Okay, then data scientist saying that okay, if this job is starting, and if this job starts after that data started arriving. Okay, because there is a dependencies, right? If you see this, there are lots of dependency on each. This dependency is so complex. See this dependency model, right? And if there is a these are the teams who are working, right? So there are this clickstream team who is working their operational data team, marketing data team, product data team, and then they are trying to, they have their own concerns. They want to know how do I fix and redeploy this job. This team wants to understand how to ensure that data is reliable so that I can use it in my product data mapping, or I want to use it in my product catalogs, right? So all these have so much complexities involved, right? And this is making it more difficult. So what are the, if you summarize these complexities, first of all, hard to build and maintain the table dependencies because lots of dependencies between different tables. Difficult to switch between batch and stream processing because the data is coming from both the sources, stream processing as well as the batch processing. And at the end of the day, you want the data from both ends and then massage it and use it. But difficult to do it because the data is you need to switch between the two different batch and stream processing. Then another problem which makes it more complex is it is very difficult to monitor and enforce the data quality as and when the data is coming. It is difficult to trace this data for the lineage purpose, okay? Because without lineage, you cannot put it data quality in place. Then data operations. So it is very difficult to observe this data at a very granular data level. At a very lower level, it is very difficult to observe it. There are no mechanism to error handling and recovery, because if there is some error happen at some point of time in the data pipeline, and recovering it to the previous state and how to understand where the error is coming from becomes very complex and very difficult. So okay, so what is delta live table? Delta live table is a simplest way to build and manage the data pipeline for high quality of data. That means it provides you easy pipeline development and its maintenance, because most of the tool, if you see, they provide a easy development. Like ADF, they provide a very easy development, but when it comes to maintenance, it becomes a big issue, right? And how it provides a easy pipeline development, because it provides you declarative tool. Okay, so declarative tool means you have to declare some options, and then once you do all declarations, it is ready to be used. And it is very easy to manage the batch and stream data simultaneously, so you don't have to switch between streaming and batch data. Then another good quality about Delta Live is it provides you automatic testing. Okay, because it has a built-in quality controls wherein you have those controls where you want to say, okay, my data for first column should be this, second column should be this is a schema, and it provides you all that automated quality controls and automated testing. Then it also provides you simplified operations for operational folks, right? Because once you deploy it, it should be easy for anybody to operate it. So how it provides that? It provides you automatic error handling, deep visibility into pipeline operations. You can customize it with the code. So that is why Delta Live Table is a way forward, and it is becoming industry standard. Now, how Delta Live Table helps to create dependencies between source, and it provides the ease of development. So first of all, Delta Live Table understands and maintains all the data dependencies across the pipelines. Like in this example, if you see, there is this configuration, and it helps you to understand that these are the data sources, and these data sources are dependent upon each other. Then it provides you declarative way to build data pipeline with business logic and change the table dependencies. So in this example, if you see, these are the dependencies which is kept here, and if you see, these are the configurations, right? You are creating a very basic standard configurations, and these configuration can be created either in Python, Scala, or SQL Server, SQL code. So this is how easy it is if you are from Python background or SQL background, or Scala background, you can easily do it. Just put a dependency. Now, it is also very easy to run in batch and streaming mode. It also provides a complete load on the data set or incremental load on a data set. You can create one pipeline and reuse it in multiple places. So that means it provides you more reusability. Like all the ETL tools, very difficult to reuse them, right? And moreover, it provides you different options to develop in different type of IDs, like Databricks Notebook you can use, or different IDs like Visual Studio Code you can use. So how Delta Live Table helps you? It provides you a single source of truth, okay, which have all the transformation logic and everything in it, right? So how it provides that single truth? Because in this example, if you see, we create a live table with a SQL syntax, and it also provides you the different quality perspective, right? And that if this particular field expects a timestamp, which should be more than this particular value, right? So this way it provides you option to prevent bad data from flowing into the tables. It also helps you to detect the errors and then what we need to do when the error is found. Like in this example, if you see, it provides you error handling option. If this error comes, you want to drop that record or fail complete pipeline or quarantine this data. So all these options are there. And then moreover, you can visually inspect the pipeline instead of getting into the code, looking into the code to understand which is dependent on what, and then debug it. So it provides you very good visualization so that you can debug this pipeline and understand the lineage. And moreover, it also provides you a event log, okay, which this event log helps you to understand which event was fired, which pipeline was fired at what time, and what are the sequence of these pipelines. So this way, this code which you are developing, actually it is actually your data, but that is working as a code, and it is a trustworthy way of working. So how it increases the reliability and maintenance? Because Delta Live Table provides you multiple options. Okay, you can definitely put a full refresh, or you can start an incremental one. Okay, so this way, you can replay this pipeline. Okay, it also helps you to use the Delta Live Table, because the core foundation of it is Delta Live Table, and Delta Live Table provides you multiple automatic optimization options like Z order, right, and all other options, which is already there. It is built on the top of it. That's why it eliminate the maintenance, right? So you don't have to perform extra set of maintenance to maintain your pipelines. Now, how it helps you to manage your workflows? If you remember that in the time of Apache Airflow, right, or in ADF, Azure Data Factory, right, these Apache Airflow or ADF is an external orchestrator. That means your pipeline might be running via a shell script or Hadoop job, okay, and that orchestrator is calling this pipeline, okay, to get the job done. And then once the control is so first job is this, and then control goes back, and then second job is this, then control will go back. Like that, in sequential order, this works. The problem with this approach is that, and I have seen this in multiple projects, that if first of all, if there is some problem, the error is coming in the orchestrator, right? In Airflow, it is throwing some error, right? And you need to understand that error and then go into the job and understand what is going there, and then debug it. Okay, so sometime what happen if your Airflow or ADF is not working, and job you cannot debug it, right? Because they are they are calling each other like this. Airflow is calling this, and then it is returning the response to this. So it is very difficult to monitor, because we need to monitor two different places: the Airflow separately and then these jobs separately, right? And then cost is also different, because ADF is different cost you are paying, and then this Databricks you are paying a different cost. So how do we simplify it? So Databricks came with this option of Delta Live Tables. Delta Live Table provides you orchestration, and within the Databricks itself, you don't need external orchestrator. And in this, you can visualize these dependencies between the different jobs. What are the dependencies? And if you want to use You can use the external orchestrator, but you really don't need it because it's already there. You don't need two different components to work. And then it provides you very tight integration, within the same console. So that is why it is simplifies the workflow management. Now let's understand what is the concepts involved in Delta Live Table. So first concept is called pipeline. Pipeline is nothing but a directed acyclic graph or DAG, which is linking different data sets to a target data set. So in this example, if you see, there is a customer data set and sales order raw data set. And once you process in this sales order clean pipeline, and then it produces two different outputs: the sales order in China and sales order in a different country, right? So this is how it is showing you the directed acyclic graph. This is called the pipeline. Now, what is a pipeline setting? These are the different pipeline settings when you create a pipeline. So first is that you are asked about what kind of feature you are using, what edition of pipeline you are using. There are three editions: Pro, Core, and Advanced, and I will explain you what are the different options there. It will provide you the different notebook path. Okay, so in this case, this notebook path is there, where your notebook will be used to run the pipeline. Then you can also add the key value pair so that you can use this key value pair while you are running this notebook. It also provides you option to use Metastore for the target DB. So you can use target DB, anything like external DB or Databricks Metastore, right? It provides you option to trigger this pipeline. So there are two modes to trigger. One is a triggered mode, wherein updates each table whenever the data is available and then stops it. And then continuous is update table continuously as and when the data is coming. So these are the two modes. So these are the pipeline settings. And once you have these settings, you can click save and this setting is saved. Then another important concept is called datasets. So there are these datasets, views and tables. Views are something like a temporary views in SQL, and it helps to break down the complicated queries into smaller or easier way to understand the query, the way you use SQL, right? But tables are nothing but a materialized views, and the same materialized views are available in almost all the data warehouses, right? And this table, which is materialized view, is created in a Delta format. Now, these views and table types are having two different types. One is a live viewer live table, and then another one is streaming. So live is nothing but it gives you the result of the query. Whatever the query you are written, it's going to give you that result of it. But streaming view is the view which processes the data that has been added since the last pipeline update. Okay, so that means if suppose you added new data set after the last pipeline ran, then that particular data which is streamed, that will be updated. Okay, and if the query changes in the data set, the view will also change or the table will also change. So this is called the streaming data set. Now another concept is how you can use this very effectively is because in a traditional environment you try to move your development copy to QA and then from QA to prod, right? And while movement from one environment to another environment is difficult, sometimes something is breaking in one environment and then sometimes it works in another environment. It's very difficult to maintain all this infrastructure. So on the top of it, Delta Live Table provides you two options: development and production. Development mode reuses the cluster, okay, so that whenever you are debugging anything, right, you can reuse the same cluster, and instead of restarting this cluster, you can reuse the same cluster. And if there is some changes you are trying to do, then you can do that changes. So this is a development, and it disables the pipeline retries. That means pipeline does not have to be retries from the start and then again fix the errors, right? So this is a development mode. But in the production mode, whenever a cluster error comes, like memory leak or stale credential, wrong credentials or old credentials, then the retry happens, and then specific errors, whatever error is thrown, based on that it retrieves back and then starts the production. So this is the two differences: production mode and development mode. It's very easy to do, click development or production here, and it goes into that mode. Then there are these additions which is provided by Delta Live. One is Core, Pro, and Advanced. Core is very good for streaming and ingest workloads. Okay, so it's a very basic one. Pro is good for your change data capture, or your updating the table based on the source data set changes, and plus all the core features. And then the final one is advanced. Advanced supports core and pro, plus it also adds you different kind of data quality constraints. Like there are some data quality constraints which we will look into the demo. So these are the three features. So depending upon your need, you can use a particular set of additions. Okay, so now Delta Live provides you a unique capability of monitoring the events happening in the Delta Live tables. Okay, so if it creates a event log, okay, an event log is stored in this path slash system slash events under the storage location where your data set is located. Like in this example, if suppose your data set is, if pipeline storage is configured is in this path, then your events will be stored in this path slash system slash events path in DBFS. But if your storage setting is not configured explicitly, that means if you are not putting this storage setting in the configuration, right, then Delta Live creates this automatically by slash pipeline ID, and then it adds this slash system events at the end of it, and then create all the events inside it. So this is the event monitor options provided by it. And we will look into it in the demo where we will capture those events and then use these events.
Thanks for watching, and do not forget to subscribe and hit the bell icon so you don't miss